So welcome all to this problem solving session. It would be if you have attended the other sessions on week 10 before this, I guess it would probably be the same. So I would be solving questions based on assignments which were given in the last run of this course. There are only 2 or 3 questions, I guess, and there are 2 or 3 again programming questions. So I'll go through the theoretical questions first, and then I'll go through the programming questions. If you have any issues, you can stop and ask me, and also towards the end, if you have any questions, you can ask me. Right. So the first question is this one. So suppose you have a single cluster of data points, and the data points are -2, -2, -1. So the 4 data points, the coordinates of all are given, and find the data point x which has the highest average L2 distance with respect to the other data points. So it's basically a matter of calculation. So let's just do it and see what comes. So -2, -2, let's say this is my data point. I'll just take the square of the L2 distances, and so the distance of -2 from 2 is 0 plus 0. So this is fine. Then the distance of -2 comma -2 from -1 comma -2 would be 1 plus 0. I am doing this, this is nothing but x square, x1 minus x2 whole square plus y1 minus y2 whole square. So I am writing those y1 minus y2 whole square and x1 minus x2 whole square values like this. Right, okay, so this is x0 plus 0. The second one is the distance of -2 from -1 -2 would be 1 plus 0, because -2 minus of -1 is -1. Then -2 and 2 1 would be -2 16 plus -2 -1 16 plus 9, and the last one would be -2 minus 1, which is 9, and -2 minus 2, which is 16. Okay, so this turns out to be 25 plus 25 50 51. So 51 by 4 is the average L2 distance with respect to the other points when we consider the point -2 -2. Let's consider the point -1 -2. So the distance with respect to -2 -2 would be 1 plus 0. Again, this is x square, this is x1 minus x2 whole square plus y1 minus y2 whole square. So if you have any issues, you can stop and ask me. Right, so the second point would be 0 plus 0. From -1 -2 we have 9 plus 9, and from -1 -2 we have -1 minus 1, which is 4, and -2 minus of 2, which is 16. So this is 20 plus 39 by 4, if I am not mistaken. Right, then we have my 2 1. So if we have 2 1, then the distance from -2 -2 would be okay, I guess 16 plus 9. Then from -1 -2 would be 9 plus 9. This would be 0 plus 0. This would be 1 plus 1. Right, yeah. So this is again 25 plus 18, which is 43. 43 plus 2 is 45 by 4, and the last one is 1 comma 2. So this will be 9 plus 16 plus 4 plus 16 plus 1 plus 1 plus 0 plus 0. This would be 20 plus 25, which is 45, 47 by 4. So find the data point which has the highest average L2 distance with respect to the other data points. We see it is 51/4 and the data point is -2, so the answer would be -2, okay. This is just an exercise about how to calculate the L2 distances. You would require to do that if you do k-means clustering, so this is just an example for that. Okay, then which of the following statements is or are not true about k-means clustering? So which is the statement which is not true? The first is it is an unsupervised learning algorithm. Of course this is not true. It is an unsupervised learning algorithm. It is used for clustering when we don't have any labels. Overlapping of clusters is allowed in k-means clustering. This is definitely not true, because if you consider the way k-means clustering proceeds is we first consider some centers. Randomly we pick some points which are centers, and then depending on the distances of all the points, so depending on the distance between these centers and this particular point, we'll assign this point to one of the 4 clusters in this case. In the case when we have 2 equidistant centers from a particular point, in that case we might assign that point to any one of the clusters as we wish. So but every point should belong to only one cluster, and therefore we can have no overlap in the clusters in k-means clustering. So this statement is definitely false. It is a hard clustering technique, it is true, and hard clustering means the same thing. Like every point, you cannot have soft clustering in the sense that you cannot say that there is a 0.5 probability that this particular point belongs to cluster 1, 0.5 probability then and 0.5 probability that this point will belong to cluster 2. It is a hard clustering technique, which means that once you assign a point to a cluster, you are assigning that with a probability of 1. Therefore it is a hard clustering technique, and k is a hyperparameter. So that is also a true statement. You see that you have some measures in order to judge how good a cluster is. For example, you might talk about radius, you might talk about diameter, you might talk about the entropy, you might even talk about accuracy if you have the original labels, but mostly it's either radius or diameter. So, and depending on the values that you have, you would decide on the particular value of k. So if you remember in the course also, in the lecture also, the instructor has shown something like this. So if k goes on increasing and the diameter is on this part, so what we see is, so of course if k becomes equal to the total number of points, then all of the points are on its own, so the diameter is of course 0 in that case. But suppose, so the diameter goes on decreasing as you increase k. At one particular point you would see that k, it suddenly decreases like this. So the change in slope of this particular function, of this particular change in the diameter, is the point that you are looking at. And so this is also known as the knee method, or sometimes also called in some places the elbow method. So these are known by both of these names, so knee method or the elbow method, and therefore you choose your k based on the knee method or the elbow method, and therefore k becomes a hyperparameter. Okay, then we have some programming questions. So 3 and 4 are all programming questions. So and 6 is also a programming question, except for 5. So 5 is actually dependent on the previous 2 questions, but it is much more general concept, and hence I will solve it here itself. So let's say A is RAND index. So what is RAND index? RAND index is defined in this the formula for RAND index is defined in the previous question. So suppose you always look at, so in RAND index you always look at pairs of elements, right? So you look at you look at 2 elements. So you choose in NC2 ways 2 points from the data set, you choose them, and you see that whether those 2 points number of times a pair of elements occur in the same cluster in both sequences, and the number of times occur in different clusters in both sequences. The two clusters are given by the ground truth labels and the prediction labels using clustering as directed in okay. So that is a okay. So what you will do is, you know already that you have the ground truth. You have the ground truth of the points of two specific points, let's say A and B. Let's say A1 B1 and A2 B2. So these are the 2 points that you are looking at, let's say. Now you already know that A1 and B1 should belong to the same cluster, and A2 and B2 should belong in the same cluster. You already know this. This is your ground truth that has been given to you. Now you run some clustering algorithm, you run k-means, you run Birch or whatever, and you cluster all these points together, and you cluster all these points A1 B1 A2 B2, you cluster somehow, and then you have your cluster assignment of A1 B1 A2 and B2. Once you have your cluster assignment, you check. Suppose you have to choose 2 points, so let's say you choose A1 and B1, and in the cluster, in the ground truth, you know that they belong to the same cluster. After you have done your clustering, you also check the same thing, whether A1 and B1 are there in the same cluster or not. If they are in the same cluster, then you add 1. Suppose you now choose A1 and A2. You know that in the ground truth they belong to different clusters. You do the same thing here, that if they belong to different clusters, you add 1. If they belong to the same cluster, you add 0, right? And in this way, for all NC2 pairs of points, you either add 1 or add 0 to your numerator and divide that by NC2. So this is your summation which I talked about, and you divide by the total number of pairs that you could have chosen from the entire data set, and that becomes your RAND index. So of course it's an indication of how well you have clustered, and that is RAND index. The other thing is you want to have something called accuracy. So accuracy is quite obvious. I mean, accuracy is the same thing as to say that okay, this all these points belong to cluster 1, and all these points belong to cluster 2. So how many of the cluster 1 points have I been able to classify correctly, and how many of the this other points have I been able to classify correctly, and that gives you a sense of accuracy. So of course, whenever you talk about RAND index, you are talking about pairs of points. However, when you are talking about accuracy, you are just talking about a single point, and therefore there can be no relation between RAND index and accuracy. One thing which you can think of is, if your accuracy is more, your RAND index will also be more, but even that you should not think about any correlation between rank index or accuracy, and therefore there should the question this is, how then are RAND index and accuracy from the previous 2 questions related? It's just that they are not related in any way. All these equations doesn't matter. RAND index and accuracy is not related in any way, because one considers pairs of points, the other just consider a single individual point in one go. Okay, so these are the I will probably talk about one more interesting question. I don't know whether it would be suitable to talk about that, but I'll maybe we'll discuss about that once I go through the programming questions. I'll discuss about that. Okay, so now let me stop sharing this screen. I'll share my laptop screen. Share my screen. Yeah, is my screen visible to everybody? Hello?
No, I can't see.
Okay. Is it the same for everybody else?
It is clear.
Okay. So I guess it's a problem with uh, some of you. You are not able to see my screen, but I am sharing. And okay,
I'll
so
just disconnect. Kindly join me again.
yeah, okay. Can you see my screen now?
Yes, it's visible.
Correct. Okay. So this question is pretty simple. Like what they have asked is, there is a data set called MNIST. So MNIST data set is MNIST data set is I think you know this already. Like it has a large number of numbers and written, I mean 0 to 9 written, and we have to find out we have to classify them. I think the MNIST that they have asked in this particular assignment is a smaller version of the same data set. So what we have to do is, here we don't use the labels, at least for computing, because we are using clustering. We don't use the labels, we just use the features, and we cluster them, and we see what happens with we see the accuracy of the different algorithms. So k-means and BERT, these are the two algorithms. I'll show you the questions after this. So k-means and BERT are the two algorithms that they have asked us to write. So let me go through the code. So NumPy you will import, because it is the numerical package which is provided by Python. Then sklearn.cluster is the one which provides you all the k-means, BERT, all the different clustering algorithms, and datasets. This is there for getting the MNIST dataset. And this plotting, sometimes you might want to plot the datasets, plot the clusters, plot something. So for that you might sometimes need to do this. Okay, so coming to this particular so seed of 42, this is of course you have seen that k-means is very sensitive to the starting point, and the starting point is a random variable, and that random variable is dependent based on the seed that you set. So for getting the answers, seed of 42 has been set. You can of course change your seed, and probably k-means will change its answers accordingly. This is the way to set the seed for NumPy. So what you need to do is you need to set a seed of 42, and then you do at np.random.seed of seed. So these are all okay. Then we come to the this is how you create the data set. So MNIST equal to datasets.load digits, and so all the data will come into X, and all the target variables will come into Y. So I'll just comment this and see the shape of this. So the shape of this is one. So there are around 1797 data points, and all of them are 8 cross 8. This is not the actual MNIST. The actual MNIST would be 28 cross 28, and 7. So this 64 would go up to 784, and this would be, I think, around more than 30,000-40,000, I guess. For training, at least you would require, total there are 60,000. So but this is a smaller version of MNIST, as I said, so that's fine. Okay, so I'll remove this again. Right, so this is so this particular function is how you calculate the rand index. So I'll come to this. So and these are the two estimators that you want. So the two estimators that you want are one is k-means and the other is Birch. Birch of 1 because threshold has been set to 1. Okay, so let's now look at k-means first. So for name EST in estimators, so that will give you the name which is k-means and the estimator. You fit and predict x. So you take x, you take the features, you don't require y in this case because this is an unsupervised algorithm. You take x directly and you try to cluster it based on the features. As soon as you, so let me show you what happens. So this actually is an interesting thing. So let me show you what happens when you predict y. So this is prediction of y and this is prediction of the actual y. This is y. Okay, let's see. Right. So you see this 0 1, I mean of course, okay, this has 17, so that is why it is. Let's see the first 100. Yeah, you see here, I mean these are the two outputs for k-means. The next are for Birch. So Birch, I mean it is the same algorithm. I mean it is just an algorithm. So I'll just follow with, I'll just explain the k-means one. So what is happening here is you have 0, you have 5, 5, 9 and so on. These are all your clusters. Okay, these are all the cluster centers that has been assigned to the clusters that have been assigned to the particular points by k-means. That is the first, this particular vector, this is y prediction, and the next vector is y actual y. So you see in most cases it is wrong, right? I mean 0, 5, 5, something is wrong. The first one is matching, after that mostly it's not matching. So okay, can anybody say why this is happening? I mean, is it like, is it expected, or I mean what do you think just by looking at this? Is there anything wrong that we are doing, or why is this happening? Why is the cluster assignment so bad? Or is the cluster assignment really this bad, or are we looking at something and not interpreting it correctly? Anybody, any thoughts? You all can see this code, right? I mean, you can see this output also.
Yes.
Okay, so okay, see what is, I'll tell you what is happening. The cluster assignment is actually, I'll just tell you the accuracy first, and then maybe I will come back to this question. Okay. Say accuracy for k-means is 79%. Rand index, okay, but rand index anyway you won't be able to I mean that another function will calculate, but accuracy, just by looking at the first 100 examples, it is very clear that of course this is 79 of them are definitely not correct. So now can you say that that means that what we are seeing here is something else, and the way we are interpreting is it not correct, interpreting it is not correct. So can somebody now say what is happening? I mean, you can say anything. I mean, you can even be wrong. I mean, I don't. Can you say anything why this is happening? Because as you see, 79% is not the accuracy for the first 100 points, but overall we are seeing 79% accuracy. So what is going wrong? Where is our interpretation going wrong? Anybody, any thoughts? Okay, no thoughts. Okay, see what is happening here is I did not really want to, I wanted one of you to at least attempt this. Okay, so see, basically what is happening here is these are your cluster assignments, right? These are the clusters that have been given to by k-means. K-means had no knowledge that what was 0, what was 1, what was 2, what was 3 and so on. So k-means probably gave something else completely. So probably what is happening here is, if you see carefully, k-means has given the first point 0 and the true answer was actually 0. So let's search for the other places where k-means has assigned 0. So this is another place where k-means has assigned 0. Here also you see that the assignment is 0. Here k-means has assigned 0. Here also you have assigned 0. Here, 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 here and so on. So probably whatever k-means has actually assigned as 0 is at the actual class 0, is actually the digit 0. Okay. Now let's look at 5. K-means has assigned 5 here. It is actually 1. K-means has assigned 5 in the next case as well. It has it is actually assigned 2. It is actually 2, the class 2. Now let's look at this 5. It is 8. Next k-means has assigned 5 here. It is also 8. Next k-means has assigned 5 here again. That is also a 8. 5 here again. That is also a 8. 5 here again. It is a 2. 5 here again. That is a 2. 5 here again. That is a 8. Right? 5 here again is a 2 and so on. So 5 is all mixed up. So that means that of course k-means will do some errors because it is an unsupervised clustering algorithm. However, it has assigned, it is not like it has assigned 5 arbitrarily. It has divided it into 1, 2 and 8. So the next part of the code is basically looking into that. So I will remove this part. So I hope you are all aware of the data structure dictionary in Python. So what it does is it gives you, so let's print this. Yeah, so this is a very simple dictionary. Like 0 is so the first part, I mean dictionary is this comma separated data structure where the first part is called a key and the second part is called a value. So it's a key value pair. So you have this 0 and it also maps to a value of 0. 1 maps to a value of 1, 2 values maps to a value of 2 and so on. So everything maps to everything, everything maps to the exact same thing. So you might be thinking why I am doing all this, why I have created this data structure. So that would be clear after I go through this. So here you see what I am doing for I in mapper. So whenever I am doing for I in mapper, it means I am going for 0, 1, 2, 3 and so on. So I will go by I will traverse the keys in the dictionary whenever I do for I in mapper. So I am going for each value. Let's say I am going for the value 2. Let's say I am going for the value 2. So what it will do is it will go in this, it will go into the target and say where all my prediction, it will choose those indices in the target where my prediction is actually 2, right? I hope this is clear. This particular this particular operation ypred equal to I, what it will choose, what it will do is it will go and it will check all the indices in ypred where this where the particular value is equal to I. In this case, let's say I equal to 2, and it will pick up those particular y values. Okay, so what this basically means is it will pick out all the indices in the target, in that actual target where I have predicted a particular value. So let's say I have predicted 0 in my k-means clustering. So it will go ahead and choose all the values in the target where the prediction has actually been made to be 0. This VC comma counts is nothing but it will give you a unique items. So as you saw, when I was predicting, when I was actually predicting I think 5, it is actually predicting 1, it is predicting 2, it is predicting 8, and all those things. So what it will do is it will say that among all those values in the target, what are the counts of the individual values that I have seen, and what are those values and what are the counts of those particular values. Okay, and then in the mapper of I, it will say that okay, out of all those values which were there, which is the maximum possible, which is the most frequent target which I have predicted when I have actually predicted, let's say I have actually predicted 5. Okay, let's just do this and maybe it will be clear. Mapper, okay, it will not work like this. Okay, if I equal to let's say 1, else break. Oh, I have not printed. Okay, let me print VC counts. Let's see, I should only run for k-means. If I equal to 1, why is it not printing? Continue, sorry, I should print VC counts. Yeah, so what you see here, okay, let's just for now let's just talk about only k-means. So I'll remove this, I'll remove birch. Yeah, so here what you are seeing is, so I have just said that when I am looking at I equal to 1, so that means that of all the cases where I have predicted I equal to 1, what are the actual values of the target there, and I am taking a count and a unique of all those. So you see that these are all the values that were mapped to 1. These were all the target values which were actually marked as 1 in my after my k-means clustering, and out of those 2 has been marked 1 in my k-means clustering 2 times, 3 has been marked 12 times, 5 has been marked 41 times, 8 has been marked 50 times, and 9 has been marked 139 times. So basically then what you can assume is, since your k-means clustering has marked 9 by the cluster index 1 maximum number of times, your k-means has actually found out the cluster of 9 and marked it as the cluster of 1. Is this point clear to everybody? Any issues you can, so if you don't say anything, I would consider that this is fine and go ahead, because this is the only thing that is left. Okay, then I think it is clear. Great. So as you saw here, then so this would give me, for example, when I equal to 1, this would give me 9, this VC of counts.argmax. So this will tell you the maximum count, I mean where is the particular index where the maximum count has occurred, and that would give you the argmax of this. So for example, if you take a count argmax of this, it will give you the index of 0, 1, 2, 3, 4, and then you are taking the 4th point in this particular array, and that comes out to be 9, and therefore what you say is my mapper of I equal to 9, which means that what was 1 before, what was 1 in my target is actually 9 in my k-means. So this is the way in which you have to calculate the accuracy in k-means, because in k-means the clustered indices that will be returned to you is not in your hand, right? Okay. Okay. Yeah, so after that you just vectorize this. So this is vectorized because I mean, I will show you. I will first maybe show you the mapper, how the mapper looks. Yeah, so if you see the mapper in this particular point, at this point, so before you have done all these different things, this was the mapper that was before. After that the mapper has become like this. So 0 is still indicated by 0, 1 is indicated by 9, 2 is indicated by 2, 3 is indicated by 1, 4 is indicated by 6, and so on. So all the things have got jumbled up. These are your clustered indices. Okay, so so the mapper is clear. Now let's look at the prediction. Let's look at prediction before, let's look at prediction now. So it's exactly the same thing. It's just that the indices have been changed. So wherever 5 was there, they have been replaced by 1, 1 has been replaced by 9. Okay, so now you can compare this y pred with the original target y, and that would give you a 2 value of accuracy. So y equal to y pred, this is actually a boolean, this will actually give rise to 1 or zeros, a matrix of 1 and zeros. You sum them up and divide by the number of elements in the particular array, and that would give you accuracy. Now finally coming to rand index. So rand index is actually much simpler. You take y and y pred, you take this y and y pred, and you go to this particular code. So what it does is you have a count of 0, you take the total number of elements which are there, then you go for you check for all the pairs of elements, and as I said, you check for if one particular element. So if remember, rand index takes in y and y pred. So the first one is the target and this one is the actual prediction. Y is the prediction, x is the target. So if something belongs in the same cluster in the target and something belongs in the same cluster in the clustering also, after clustering also, or something doesn't belong in the same two things doesn't belong in the same cluster and the similar two things don't belong in the same cluster even after clustering, then you add count, you increment count by 1, and once you do that, you do this for all pairs of points, and NC2 is n into n minus 1 by 2, you return the count by n into n minus 1 by 2. So you do that, and so the accuracy for k-means is 79% and the rand index is 93.3%. So accuracy is much lower. I mean, for this particular data set, for any supervised learning algorithm, it will give you close to 100%, but of course this is an unsupervised algorithm and therefore it is giving a much lower accuracy of 79% and rand index for k-means of 93%. Let's also run it for BERT now.
So can you explain argmax again?
Yeah. Okay, let's argmax for, I will take a simple example. Let's say I have an array which is np dot array which is 1 2 3 4 65 3 not 3 30 12 whatever 27. Let's say this is my array and I do np of argmax a. So this is your array, the maximum element is 65, np.argmax will give you the index where the maximum element is situated, which is 0 1 2, 3, 4, the fourth index, and you have got 4. Is it clear?
Yes, sir.
Okay. So you see that for accuracy for k-means is this 79%, RAND index for k-means is 93%, Birch is probably giving you a better result, it is 86% and 96%. Yeah, so these are the two algorithms that now if you don't have any more questions for this code, I will go back to the assignment and discuss. I mean, I'll just show these two questions and that's it. So any questions from this code? Okay, then I'll stop sharing this. Yeah, so we have come back to the same PDF. Now label the prediction. So as we saw, what is the accuracy? So basically run k-means on the input features of MNIST dataset using the following initialization. So this was the initialization that I had set. Seed was given to be 42 somewhere. I don't, okay, maybe I have missed that part of the question. Seed is actually set to be 42. You have to set it to 42. So label the prediction. For all the label, so this is the thing that I had done. Label the prediction class for all the points in a cluster as a majority true label. What is the accuracy of the resulting labels? It was 79 point something, so that is the one. What is the RAND index for this? I don't remember. I think it was 0.93. I don't remember.
Yes, 93.
Yeah. Thank you. So for this is 93. And then run Birch again, n clusters and threshold of 1. What is the RAND index obtained? That was 96. So we have done these 3 coding questions and gone through some very basic theoretical questions. So I will give you one more question which is a bit intriguing. So before that, if you have any questions, you can ask me.
Yeah, if you don't mind, can we do from assignment 10, question number 7?
Assignment 10, this current assignment, is it?
Not the one which you are displaying, the one which is given to us.
No, that I am not allowed to do actually. The present assignment I am not allowed to.
Some hint on similarity matrix and how to find the
I am not aware of the question. Let's see, because sometimes they send mails saying that you are not supposed to solve problems which are there in the present session. So let me see.
No, it's okay even if you don't solve the one which is there, but some hints can we get how to solve that question?
Yeah, let me open my system. My system is hanging like anything. So just give me a minute. Yeah, I think it is about the hierarchical clustering, single link clustering and so on, right?
Yes, correct.
Yeah, so basically what you need to do here is P1 and P2, the similarity is given. Okay, so so similarity means it's an inverse of distance. You can think of similarity as an inverse of distance. So P1 and P2 being very similar to each other means that the distance between them being very less, so what you need to do is, this is a bottom up clustering, so you need to check which are the closest points which are the closest points, like P1 and P2, which are the closest points, so between all these pairs of points like P1, P2, P3 up to P6, which are the closest points, and you merge them first. I guess if you do that itself, you will get the answer, I guess so. Yeah, I mean, just by looking at the similarity matrix, you need to find out which are the 2 points which are most similar to each other, and you need to merge them first, because that is the way this entire clustering algorithm works. So yeah, I can't solve this problem.
Merging, no, it's okay, that I understood now.
Yeah.
To find the closest point. So
Yeah.
merging in the sense, what are we going to do?
Merging in the sense that in the dendrogram you will see that you will just take 2 bars and connect them together. That's it.
Okay.
So if you follow that, then it would be I mean, it's the same logic basically. Okay.
Thank you.
And then once you the other thing is, I hope, okay, I'll close this because this is right. So this is single link clustering. So that means, suppose if you merge 2 points 1 and 2, and you have merged another points, let's say, I mean, this is of course an example. So 1, 2 and 3, 4 you have merged, and now and you have also merged the points 5 and 6. Let's say you have got this. Now you have to merge either this, or you have to merge this, or you have to merge these two. I mean, is this diagram clear, or should I explain it once more?
If you're comfortable, once more would be better, else no issues.
Yeah, let me draw it a bit better. Let's see. Suppose you have 6 points. You have merged these 2 points. After that, you have merged these 2 points. After that, you have merged these 2 points, right? Now you are supposed to merge clusters. Now this means that these are already clustered, these are also clustered, these are also clustered, but now you have to do you have to merge clusters now. So one possible direction is, again, if you have, so one possible direction is this, and this stays as it is. The other possible direction is this, and you can understand the last possible direction would merge these two. Now,
Yes.
when you are doing single link clustering, what you need to do is, these are your clustered elements at this stage. You need to find out the similarity between all these pairs of points. So let's say you have 1, 2, 3, 4. You find out the similarity between 1, 2, 1, 3, 1, 4, and what else is remaining, 2, 3 and 2, 4, right? I guess those are all the pairs. 1, 3, oh sorry, 1, 2 you don't need to take because they are already part of the cluster. 1, 2 you don't need to take. So you will take 1, 3, 1, 4, 2, 3, 2, 4, right? These are the 4 similarities that you will check. Similarly, you will also check suppose these points are 5 and 6, 1, 5, 1, 6, 2, 5, 2, 6. you will also check this, and you will also check 3 5 3 6 4 5 4 6. So all these different similarities or distances you will check, and you will take the minimum of all of them. Like you will take the minimum among these 4, you will take the minimum among this 4, and you will take the minimum among this 4, and whichever one will be minimum among all of these, you will merge those two. Let's say among all these, these will be 4 into 3, there you will have to check 12 similarities, and out of those 12 similarities, let's say 1 3 is the lowest. That means you would go and merge this. Is this clear now?
Okay.
So that is the way you go about in single link clustering. For average link clustering, I think you will take a similarity and take an average of all of them. For complete link clustering, you will take the maximum at this stage. You will take the maximum at this stage and then take a minimum of all these 3 values. So that is how you can go about doing that, solving that question. I hope I could give some idea about how that question can be solved.
Yeah, we will try.
Yeah. Any more doubts?
But like this similar one, now the assignment, after the assignment is submitted, can we solve one next week?
Yeah, I'll try to solve one next week maybe. Yeah.
Yeah, thank you so much.
Yeah. Okay, so
Sir, can
yeah.
we try this above question using different example?
Right now it's very difficult to set up a question based on this example, because this requires a proper matrix denoting all those things properly. So maybe next week I will create a new question based on this single link clustering and complete link clustering, and I'll solve that.
Okay, sir, no problem.
Yeah. Okay,
Yeah,
so
one more only
yeah.
doubt I wanted to ask.
Yeah.
In the k-means, when if a data set is given,
Right.
and then we are asked to find final clusters. So in that case, too many iterations are going to come, no? So is there any shortcut to solve, or we have to keep on doing given the centroids and then keep on subtracting and finding out centroids, and then again taking the average and keep on doing that till we land up with the last cluster? Because that would be very much time consuming, no, in the examination to solve.
In k-means, you would, I mean, if you are solving by hand, then ideally it shouldn't, the problem should be set in such a way that it shouldn't take many iterations. But normally in k-means, you would have to continue doing the k-means algorithm unless the difference between the cluster centers that you are computing in 2 consecutive iterations is not changing much. That is the stopping criterion.
Yes. Because in the first, in this assignment only, the first example,
right?
Actually at the 4th iteration, the centroid, and the data points are also almost 10 to 12 data points are given. So, and 3 centroids. So it is very time consuming.
Right. Yeah. But you have to do that. So there is no other way to stop k-means.
Okay. If possible, take one this next week. This type also one, if possible.
Okay, fine. I'll try that. Yeah.
Thank you very much.
Yeah. So I'll maybe give you one more question to think about. I'll not tell you the solution for this. So think about a question. Think about a situation. This is a very practical situation that you might face. Let's say you have all these different points. I hope these are clear. Let me draw a bit bigger maybe. These are one class and the other class is like this. Okay, I hope the 2 classes are visible, and these are basically concentric circles. Can anybody suggest, suppose this is the origin, this is how your data set is created, I mean how your data set looks like. So can somebody suggest what the k-means, I mean, and you would also know k equal to 2. K equal to 2 has been told. So let's say you know that there are two classes, somebody has come and told you that k equal to 2. Can you cluster these 2 points? I mean, and you will run k-means, of course. So can you separate out these 2 classes of points by k-means? That is the question. Is this possible, or else what do you think k-means would end up with? Which point k-means would give at the cluster centers, 2 cluster centers? Anybody? Because you have looked at k-means, that is why I am asking you this question. I mean, any guess also is fine. I mean,
Could you please repeat the last?
yeah, so this is how your data set is distributed, and you run k-means with k equal to 2. So k-means will return you 2 centroids, right?
Correct.
What do you think the 2 centroids will be? If suppose this is the x-axis, y-axis, and this is 0, 0, what do you think the 2 centroids would be?
The centroid would be same only. No?
So it will be close to the origin, right?
Correct. Yeah.
So both the centroids will come near the origin, and in that case you won't be able to separate out the 2 clusters.
Yes. Correct.
Correct? So the question would be, is there any way in which you can separate out this particular data set using k-means itself? You don't change anything. I mean, you don't change anything in the k-means algorithm. K-means algorithm remains as it is. Can you do something to this, to the way this data set is distributed, so that it becomes separable by k-means? Okay. So I will give this answer later. So keep this question in mind. And so this is a very interesting application of k-means. It's not like I mean, this is a very interesting application in the sense that I would give you a hint that you have learned something in SVM which can help in k-means. You have learned a particular trick or topic in SVMs which you can apply here. I mean, the similar concept you can apply here to make this same data set be made, this same data set can be made separable in k-means only. Okay, so
Is it something related to the distance from the origin of the data points?
It is indeed related to the distance of the origin, but then how would you look at this distance? So you think about this question. I will talk about this, I mean, once I finish all the lectures, maybe I will talk about this particular question then.
Okay, thank you so much.
Yeah, thank you. If I'll close the call and we'll meet next Saturday.
Yeah, thank you very much.
Thank you.